Uh, Today I'm going to talk about since the board exams have been started for class 12 students, CBSE board exams. Next exam for the science group students is going to be physics on March 4, next Monday. So I'm going to walk through the curriculum and what are the important points we have to know before going for the exam, going for physics exam. And also this will be helpful in preparing last minute preparation on how to manage the time and where to give the time in these 5 days. So firstly, beginning with the syllabus, the maximum marks is 70. The maximum marks allotted is 70 for the paper and time is 3 hours. So unit 1 is electrostatics. There are 3 chapters. Unit 1 has 2 chapters in electrostatics, and then unit 2 is current electricity, only 1 chapter. And first 3 chapters combinedly have allotted 16 marks. So the first 3 chapters combinedly have allotted 16 marks. So the next 4 chapters, that is unit 3 and unit 4, magnetism and also electromagnetic induction. So these 2 units have been allotted 17 marks, and then there comes unit 5, electromagnetic waves, ray optics and wave optics. So these chapters have been allotted 18 marks. Then dual nature of radiation and matter have been allotted 8 marks. So totally there in this unit and also unit 8, atoms and nuclei, chapter 12 and 13 have been allotted 12 marks. So the electronic devices, the unit 9, the most interesting part for me is this: only 1 chapter is allotted 7 marks. So you can compare that only 1 chapter has been allotted 7 marks. So as a suggestion, I will suggest that begin the preparation when you, for example, I assume that you have not started or only know some basics. So you can begin by semiconductor electronics to begin with. So because that carries the maximum marks, only 1 chapter but 7 marks. So the next second most important according to marks is chapter 8, 9 and 10. These 3 chapters together 18. So 3 will give you 18. So each chapter is 6 marks. So approximately 6 marks. It doesn't mean that each chapter we get 6 marks, but on an average you can expect that 6 marks. But 3 chapters combined you will be allotted 18 marks. As is here. So electromagnetic waves, ray optics, and then wave optics. So now let us see some important topics in chapter 7 to begin with. So chapters unit 7, that is unit 1 minute. It is unit 9 and chapter 14, 7 marks. So semiconductor electronics, materials, devices and simple circuits. It is nothing but there is a simple introduction you can go through. Then what is the classification of metals, classification of, the first topic is, the first thing we have to do in physics is try to divide the chapter into different topics and read through the topics very thoroughly. Then here is the classification of metals, conductors and semiconductors. Then there are 2 ways of classification: basis of conductivity and also on basis of energy bands. So both are important, and energy band diagrams are very important. How you distinguish between a conductor and semiconductor and an insulator. So there is some values, there is something called as band gap and other terms you have to look through in the book. And then Then the next topic is intrinsic semiconductor. So what is intrinsic semiconductor? Like only silicon and germanium are two most common semiconductors, but there are so many nowadays, but these two are very important. Then coming to in this you have to read through this, and then the next part is extrinsic semiconductor. This is doping. Then the doping is done. There are two types of dopants as here, tetravalent or trivalent. That is group 14 elements is semiconductors. So either we dope with group 13 or group 15. So if we dope with group 15, that type of semiconductor is N type. Other one is called P type or trivalent or pentavalent. So this is very important. You have to when you dope with N type, then there is electrons are majority carriers, and there are something called as majority carriers and minority carriers and those things. N type, P type, and other part is nextly going to the important part to know is this one. This formula is electron and hole concentration in a semiconductor in thermal equilibrium is given by the concentration of holes into electrons is equal to the intrinsic concentration square. This is very important law. And then it is important to some basic understanding of energy band diagram, how it will shift if we after doping and before doping. Like we already know how it is for semiconductor, but what happens after doping, P type and also N type. There is a numerical problem. Definitely this is one of the important problems you have to go through. Then the next part is PN junction. So the PN junction is almost like a ABCD of the semiconductor devices nowadays. So we have to if you are planning to do electronics major, definitely you have to know about PN junction, or you will learn more about PN junction later, but this is very important. You have to know about PN junction, what is drift and diffusion, and how it is formed. Drift current and electric field into drift and diffusion. So then there will be something called as barrier potential. These topics are quite important, and also this question example is like it is exercise. Then we come to semiconductor diode. This diode is nothing but a PN junction diode. So when P and N type both are combined, then you form a PN diode. So what happens when we apply this is nothing but just a PN junction, but diode is formed. This is only a diode, but we have to use it for some application. For that we bias it using some external voltage. That can be done in two ways. Forward biasing means the positive end of the bias, positive supply is connected to the P side and negative end is connected to N side. Then what happens is the barrier potential lowers after the biasing, forward biasing. So this is indicated here, the barrier under forward bias, V0 minus V. So this is what is concept of the carrier injection. Other things are there inside, you can look through this. And then also the next part is PN junction diode under reverse bias. So what happens when we do the opposite, like we connect the P side to the negative terminal and N side to positive terminal. This is also is given here. There is something known as we can consider that the current does not flow generally, or negligible flow, because in forward bias it will flow in milliampere, but in reverse bias the current is microampere, so it is almost negligible. And also it is important to note that which current is there. So it is important that drift current or diffusion current which dominates. Definitely you have to go through the text and know all these things. And also there is a characteristic, VI characteristics of PN diode. This curve is very important, and how you measure this characteristics is given. But measurement, I think it's been completed in the lab, so probably we don't need it. Only curve is important. This first quadrant, in the first quadrant, it is a forward bias junction. It is an exponential curve. In the reverse bias, it is almost zero, but there is something called as breakdown voltage, and I don't think the breakdown, we don't want to use it in a breakdown. So we will use it in only, there is a specialized devices called Zener diode, but that is omitted for this exam. So if I go, then there is cutting voltage or threshold voltage, like 0.7 volt for silicon or 0.2 volt for germanium. As you can see that current is 0 for some 0.6 volt approximately here. This is for silicon diode, as the cut-in voltage is 0.7 volt approximately. So from there the current starts flowing. Before that the current does not flow, even though in forward bias. But we generally, for calculation, we assume that in forward bias the diode is on, and reverse bias diode is off. So these are some calculations which can be done. This problem illustrates. And then coming to the application, the rectifiers are like, it is application of diode, but what we do is we convert AC to DC voltage. That can be done by rectifiers. Either we can do half wave rectification, that is, we pass a sinusoid or any alternating voltage, then only positive cycle of the voltage is being rectified, negative cycle is being neglected, because it is basically diode is only on in the positive cycle, but in the negative cycle it is diode is off, so it is open circuit, so no current flows inside, so there will be no output. Similarly, there is a full wave rectifier with center tap transformer which uses only two diodes. One diode will be on and one will be off in a particular cycle. You may refer the text for more details inside. So you can see that in the both cycles, one of the diode will be on. So you can see that from the diagram. In the positive cycle, D1 diode is on. In the negative cycle, D2 is on, but D2 is off. So D2 is on, but D1 is off. So both the cycles, the rectification happens. That is, the positive voltage only we want a positive voltage. So now after getting this voltage, we have to make it a constant. So make it a constant, we choose a capacitor. So we pass it through a capacitor and filter it, filter the voltage, and we have to choose a capacitor depending on the, we have to make sure the time constant is large time constant, so C value should be large, because to get the voltage should not go below again, so it should be around the peak value. So we get the this way we can get the constant voltage as output after rectification. So you have to know what is full wave rectifier and how it is different from half wave rectifier and its operation. This is one of the important questions. So you have to be, in this chapter you can see that I have divided into various topics. So you can easily go through which topics are more important. You have to read this chapter very thoroughly, because 7 marks, only one chapter gives you 7 marks, and this is a summary, and there are no numerical problems as such. So this is it about this chapter.